Welcome to your first lesson in geometry, lesson 1-2. We're going to talk about basic terms and postulates of geometry, including points, lines, and planes. So what is geometry? Well, geometry is a course we're going to be working on all year, and it's a mathematical system that is built on three things: accepted facts, we call those axioms; basic terms, those are your basic vocabulary words; and then the definitions of those terms as well. Okay? So here are some of your first things that we're going to talk about. So a point is the most basic concept in geometry, and basically what it is it indicates a location on a graph or an object, but it doesn't have a size. So no matter how big you draw that dot, it's not going to change. It's technical, the fact that it doesn't actually have a size. We name it by using a dot and a single letter. So right here in the diagram, you can see there's a dot with a capital A. And we do use capital letters to name points. Lowercase letters actually mean something completely different, so watch that case. The next concept is a line. A line builds on the idea of a point. It is represented by a straight path that extends in two opposite directions, and it has no end. It keeps on going forever technically, and it actually has no thickness. So no matter how thick you draw that line, it technically has no thickness. And a line is actually made of an infinite number of points along it. So when we name a line, we name it by 2 points, and those are by 2 points on it, like this one right here. And notice that since they're points, they're capital letters. So for example, we can name this thing as AB, and then we actually put a line above it, and that line is going to have arrows on both ends. I'm going to go get my arrows, just like that. Or, do you see this little cursive L right there? We can name it using that little cursive L, such as that, and that's when we would actually use a lowercase letter. Okay, so lowercase letters can refer to lines. Uppercase letters are points, or two of them on a line can be used to name the line. And then we have a plane. So a plane is actually a flat surface that extends without thickness. So think about it like a tabletop that just goes on forever, or a wall that just goes on forever. And a plane contains an infinite number of lines. In this plane over here, you can draw as many different lines as you want on that flat surface. When we name a plane, we have two choices. We can use a capital italic letter, such as P, just sitting over here. Notice it doesn't have a dot next to it. It's not referring to a point, it's referring to the plane. Or we can name it by 3 points that are on the plane, but are not on the same line. So see how A, B, and C, if I were to connect those dots, it would make a triangle. If that happens, then I can use them to name the plane. If it doesn't, if it makes a line when I connect the dots, I can't use that to name my plane. And that actually comes into play in these next two vocab words we're going to talk about right here: collinear points and coplanar points. So collinear points are points that lie on the same line. So like this, if I draw a line and I have 3 dots on it, these are collinear points, those 3 red dots that are all on the same line. Coplanar points are points that lie on the same plane. That's like this A, B, and C I used to name it in the picture up there. Okay? So we're going to take a look at a picture, and we're going to try to see if we can come up with some other names for lines and planes. So it says, what are 2 other ways to name line QT? The first thing you want to do is find line QT. That's right here. So if you see that when I connect those with a red line, if I extended that, that would give me all of the other points on that line, and it would actually show me that line as well. So see, I can extend that. Now if I look, Q and T are both on this red line, but so is N. So I can use any combination of those 3 letters to name it. So let's say I want to use Q and N. I can do that. So I use capital letters, and then I just draw a line above them. Now I also notice that there's this lowercase m down there. I can also use that to name my line. Single lowercase letter. Now I could also, if I wanted to, if you thought about using T and N, you could do it. Or if you wanted to switch that Q and N letter around, so it was NQ, that's perfectly fine as well. All right, so here you can see the next question is, what are the 2 other ways to name plane P? If we look at plane P, that's this yellow parallelogram we have here, and you can see the capital letter P with not a dot next to it. That's referring to the name using a capital letter, not a point. Now, the other way to name a plane is with 3 points. So if we look at our plane, I highlighted already in blue these 4 dots that are all on the plane. Now, you only need to use 3 of those in order to name the plane, but the trick is the 3 points can't make a line, they have to make a triangle when you connect the dots. So for example, if I wanted to use R, Q, and S, if I trace those, you see how it just makes a line and not a triangle? That means that's not going to work. So I try something else like R to Q to V. That makes a triangle. That'll work for our name. So I go and I put in my name like that. Now I could switch around those 3 letters in any order I wanted, and that would be another name. However, if I want to get a little bit more creative, I can think of a different connection of 3 points. So maybe Q, S, and V. That would also make a triangle when I connect the dots, making the name of a plane. And once again, you can shuffle around those letters however you want. The next question, what are the names of 3 collinear points? Well, we kind of already addressed that. You want 3 points on a line. So if I look, I first want to look for a line in my picture. So I'm going to highlight a line, maybe this one right here. And if I look on that line, I have T, Q, and N. Those would be 3 collinear points. Now, that's not actually the only set of 3 collinear points. There's another line I could look at. If I go this way, right here, on that line you have R, Q, and S. Those will also be collinear. Now we kind of addressed this other question already as well. It says, what are the names of 4 coplanar points? Well, in my picture right now, I have one plane. That's this yellow plane here. We already said earlier that it has 4 points on it. It has R, Q, S, and V. So that's what I would put in here. R, Q, S, and V. All right, so we can also use undefined terms like point, line, and plane to help us define other terms, such as a geometric figure is a set of points. It's using points to help us define what a geometric figure is, or that space is a set of all points in 3 dimensions. Those are good things to know, but down here we actually have 3 of our most important vocab words this chapter: segment, ray, and opposite ray. So segment is essentially a chunk of a line, it's a piece of it, that consists of everything between 2 endpoints. And so here in this picture you can see it's the segment AB. Notice there's no arrows on it because it ends, because it's just a chunk. And when you name it, you can name it 2 different ways, AB or BA. It doesn't matter. You just put the endpoints in either the first or the last position. And notice that above it, you draw a line or a segment that has no arrows on it. Unlike when we named the line earlier and we put an arrow above it. Then we have a ray. Now, rays are a little bit particular. So it's a part of a line. It's basically like half of a line, essentially. It's an endpoint, and then it goes in a direction. So it's everything to this one direction of that endpoint. So if you look at this picture over here, A, B, you can see A is an endpoint, and then B is telling you which direction the ray is going. And there's an arrow on one side of the ray, tell you which direction it's going. And it goes in that direction forever. Now, when you name a ray, you actually have to be really particular. You're going to use the point that is the end point as your first letter, and then the other point as its second letter, so A, B. Now, even if my ray looks like this, and maybe I have a C and a D on it, like that, you might think that you would call that ray CD because you read it like a book, but you don't. You would actually call that ray DC because it goes from the endpoint D towards C. So the endpoint is always the first letter. Then we have opposite rays. Those are basically 2 rays that share a common endpoint, and together they make a full line. So here you can see that in our next picture. Here we have ray CA goes to the left and ray CD goes to the right. They have to have that same common letter, and that is the only point of overlap that the 2 lines have, or the 2 rays have, sorry. And notice when you put them together, you get a straight line. So there's actually a lot of ways to identify rays and segments in pictures like this one here we're going to look at. It says, what are the names of the segments in the figure at the right? Now, I'm just going to go through a few of them with you. So remember, a segment has a beginning and an end. So I basically pick a point to start at, like D, and I go to another point like E. That would be a segment. So I go D, E, and then above it, since it's a segment, I'm going to draw a segment above it. You do need that. Now remember, segments do not get arrows because they stop. Now there are a few other segments in this picture like EF or DF, and you could write those down as well. All right, then this is what are the names of the rays in the figure. So remember, a ray starts at an endpoint and goes in a direction. So I pick somewhere to start at. So if I start at D and I want to go to the left, I can't. There's nothing to go that way with. So I go the other way. So maybe I go to F. D to F would be a ray. So now I write that. And I'm going to put a ray above it. Now it's starting at D and going towards F, so I do that. Put my ray to the right. Now I could also give it another ray, like maybe I want to start at E. Well, I could go to the left at E or to the right of E. If I go to the left, I would go E where I'm starting, D where I'm headed. So then it would be ED with a ray above it, like that. If I go to the right, I have EF, and I would draw that ray above it as well. What are the rays in part B or opposite rays? Well, if we look at that, I kind of already highlighted that for you if you're paying attention. Right here, you can see they have a common endpoint E. ED goes to the left, EF goes to the right. Those are your opposite rays right there. This is an interesting question. It says EF and FE form a line. Are they opposite rays? So if I look in that picture, if I look at my EF, let me clear out my picture first. Oh, that wasn't what I wanted. There we go. EF goes like that. FE goes like that. Are they opposite rays? Well, opposite rays make a line, these do, and they share one point in common. Well, these share both E and F and everything between them in common, so they would not be considered opposite rays. Okay, so we're going to go pretty quickly through this next chunk. A postulate and axiom, basically, this is an accepted statement of fact in geometry, so they're things that are just true and we don't really have to prove them or explain a ton, they just are. And they're the building blocks of logical thinking in geometry. So you don't have to remember this one, it's just something that we have to talk about. It says through any 2 points, there's exactly one line. So you can connect any points to make a line. Great. Now, they kind of build on that, make a postulate 1, 2. And basically, so if we think about intersection, it's a set of points that 2 figures or 3 figures or more have in common. It's where they cross. In algebra, we think about that as an ordered pair, or right here, like that purple point, 3, 2 of this blue and red line. Well, in geometry, we would say that if 2 lines cross, they intersect at a point C. Great. We keep building on that to do our third postulate, when planes cross. So planes, remember, those are flat surfaces. If you take 2 flat surfaces and you connect them and you trace where they intersect, you're going to make a line. And that's what this says. If 2 distinct planes intersect, that they intersect in exactly one line. A great way to visualize that is to look at a wall right now. So if you're looking at a wall and then you look at the ceiling that connects to it, if you trace that connection, what you're going to end up drawing is a straight line. Okay. Now, interesting thing is that because 2 planes cross at a line, and lines are made up of points, at least 2 points, this tells us that when 2 planes cross, they're going to also have 2 points in common. So we kind of look at this in terms of this 3D object. It says, what is the intersection of planes ADC and plane BFG? So what I'm going to do is go find those planes first by connecting the dots. So on a cube, a plane is one of the faces or the sides. So I go A, D, C, and if you look, there's a 4th point on there too, B. So I highlight that. And then they want BFG. So B to F to G, and then there's a 4th point they have in common, C, right there. So planes, we just said when they cross, if you connect it, you make a line. Well, if I look in this right now, I see a line right here where they cross. So I would say that these 2 cross, the 2 letters that they have in common are BC, and it's a line, so I'm going to put a line through it. We get a line. There we go. Just like that. Okay, so then the next question is, what are the names of 2 planes that intersect in BF? So we go find BF right here. Now, if you look at that, you can kind of see it's on this front plane right here. And it's kind of on this side plane right here. So what we do is we would just name those. Now you can use all 4 letters of those planes to name them, or you can use 3. So that front plane, I see letters A, B, F, and E. Maybe I decide to use all 4, or maybe I just go A, B, F. That right plane, I can see B, C, G, F, and I can use those 4 letters, or just 3 of them. I'm going to use G, F, B. We talked about this question already. Why do you need to find only 2 common points in an intersection of 2 distinct planes? That's because planes intersect at a line, and a line is named 2 letters only. All right, real quick, last postulate. It basically says through any 3 non-collinear points, there's exactly 1 plane. So essentially, if you've done any photography, you might know that cameras, when you put them on a tripod to get them to level when you're taking your pictures sometimes. Well, there's a reason why it's a tripod and not a quadpod or bipod. And that's because with 3 pieces of contact with the ground, you're going to make it stable and you're going to make it flat. Well, that's what they're saying here. 3 points make a flat surface, a plane. All right, so I'm going to kind of show you this, and then we'll wrap this up. It says, what plane contains point N, P, and Q? So shade the plane. All right, N, P, and Q, I go find them. N, P, Q, connect the dots. Well, there's also a 4th letter on there, R. That'd be that one, okay? What plane contains J, M, and Q? Well, this is a little interesting. I go J, M, Q. See how it cuts across? Well, it's kind of hard sometimes to tell how this cuts across, but you see on the back, it's cutting across MQ. Then on the parallel face, the front, you want to cut across to JP, just like that. So sometimes you can make planes that actually cut through a box rather than just being one of the faces of the box. All right, I'm going to skip the rest of this, and there we go. So that was the end of lesson 1 to your first real geometry lesson. And our goal was for you to kind of get a basic understanding of geometry terms, postulates, and definitions.